Good afternoon, everyone. Back with another video, doing some more OSPF study, this time with our second resource, Cisco CCNA in 60 days. We've made it up to day 24. Day 24, 25, and 26, I want to say, are all related to OSPF, and I think I'm going to try to get through the 3 labs in this book today, including the challenge lab. And then after that, we get into infrastructure services. So no more, well, officially no more routing. And so that's kind of exciting, making our way into sort of different domain, maybe is a correct term, and finishing up routing. It has been a while with routing. But I'm feeling pretty confident in my knowledge of OSPF. Still need to study some more, but as far as configuration goes, I'm feeling pretty good about the general concepts. So let's get started. Day 24 lab, you can kind of see is a basic 2 router topology. And this is just one of the standard labs in the book, and so we can check our work. I'll try to just do it without checking and see, that I can do it correctly. And if we need to, we'll check and we'll be able to have the explanations right there. And then once we get into the later chapter labs, those are challenge labs without the ability to check your work. So they're really testing you. But I think they should go pretty quick, and we should be able to get through them in this video. I think that's about it. I was able to travel to Chicago this weekend and visit some family and visit some old friends, and that was a lot of fun. And now I'm back in the St. Louis area and working. Life is back to normal. So let's go ahead and get started. Let's set up 2 routers. Let's see. We are recording, yes. And which routers, I don't really know if it matters too much, but I'll just pick these 1941 routers. All right, and they are configured according to the diagram over a serial line. So I'm going to do serial. Here we go. One has to serve as the DCE and one has to serve as the DTE. And actually recently, okay, so I've done this in the past. First of all, let me get out of that. To configure a serial line, you need to power the router off, zoom in, power it off, and plug in the serial module. Console ports, I think it's this one, HWIC. Now where it goes, there we go. HMAC, HWIC. I think that's right. All right, so then power it back on. We'll see if this works. Same thing over here. Go to zoom in, power off. HWIC2T is a Cisco 2-port serial high-speed WAN interface cord providing 2 serial ports. Okay, and then power back on. All right, and then we want to hook them up with a serial link, and now we have the serial ports available to us, so that's good. So 00 to 00, that'll work. All right, and now I think we might be able to at least test basic, we don't have IP addresses. Okay, so each of these routers, the serial link is on a 10.0.0.0/30 subnet, and then they have 2 loopback interfaces, and they each have their own IP address. So we'll configure all that. And the first step is number 1, configure all IP addresses based on the topology above. Make sure you can ping across a serial link. All right, so let's do that first. CLI, would you like to know? EN conf and we're going to do interface serial, what is it, O/O/O, IP address, and it's going to be 10.0.0.1. That's fine, I think. 255.255.255.252. This is going to be only 2 available hosts in this subnet, I believe is what 252 would give us. Let me just confirm that before I say it, and I'm not lying. How many hosts are available in a /30 subnet? 2 available hosts. All right, so that's good. I got that correct. And then what is the subnet mask equivalent of /30? 252. All right, there we go. 2 subnetting questions answered instinctively. All right, so, and I just erased it. All right, so we got to do IP address 10.0.0.1, 255.255.255.252. All right, so that has address. All right, and then I'll go over to this other router and the same thing. No en conf t. All right, and then we're going to go to interface serial 000, and again IP address, and this one's going to be 10.0.0.2, and it's on a 255.255.255.252. All right, let's see. No shut. I was going to say, how do I turn it up? Turn it on. No shut. All right, so it's changed to down. Let me do no shut on this one real quick, and hopefully they both go up. No shut. All right, so that's up. Did I get a message over here saying it was up? Yes, I did. So now I expect to be able to ping across. So can 10.0.0.1. Let's see if I can do ping 10.0.0.2. And it's successful. All right, and so make sure you can ping across the serial link. That's good. That looks like the clock configuration happened automatically. Remember, when you're doing serial links, I don't know how common they are. I get the sense that they're not as common as other types now, because I don't think you're tested on configuration of serial links on the CCNA any longer. Jeremy from Jeremy IT Labs mentioned that on a recent video I was watching. But anyway, you typically have to, you might, if it's not working, have to configure the clock rate, which determines the speed of the serial line. But in this case, we didn't have to. The pings are successful. Okay, so add OSPF to router A, so whatever, router 0 in our case. Put the, we got to do the loopback interfaces. So for router 0, all right, let me exit out of this, and we need to do interface L0. That's loopback 0, and that's changed to up, and we'll say IP address for loopback 0 is going to be 172.20.1.1, and it's on a /24 subnet. /24 is this. What am I doing? That's right. I'm having like a, what is the subnet mask of /24? Yeah, I was right. I don't know why I was questioning myself there. That was weird. All right, now then this next one, it needs to have an interface called loopback 0. There we go. And it needs an IP address of 192.168.1.1. And it's a /26, so that's going to be 255.255.255.192. That's 128 plus 64. Let me just double check. So of a /26, and I was correct. All right, I'm feeling pretty good about the subnet stuff. I might do another video about subnet mask, or no, about subnetting practice this week. All right, so that has an IP address. So those are good. All right, so for router A, let's get back out of here. this router, we are saying put the add OSPF to the router. All right, so we're going to have, okay, we have two interfaces, and it says add OSPF to router A, put the network on loopback 0 into area 1, and the 10 network into area 0. All right, so first things first, let's get out of this. We need to get into router configuration mode. So from here, I think we can say IP router. Maybe not IP, router. Okay, router question mark, OSPF question mark, process ID. We'll just give it a process ID of 1 and carriage return for the next one, nothing left. All right, so now we're in router configuration mode, or OSPF router configuration mode. All right, and so we've got, let me just move this out of the way a bit. So over here, we've got the, as you can see in the flyout, I wish in Packet Tracer that I could like click into this flyout thing that appears and have it remain visible so I could highlight things, but that's not possible. So serial 000 is on the 10.0.0/30 subnet, and loopback is on its own. So we're going to put these in different OSPF areas. All right, so remember to put something into an area, first of all, let's do our 10.0 network. So we're going to say network, and what do we need? So network 10.0.0.0, and it needs a wildcard mask. And in this case, because its subnet mask was a 252, the wildcard is the inverse of that. So that's going to be .3. And it needs a area ID. And remember, the 10.0 it instructs us to the 10.0 network, put it in area 0. So the 10.0 network is in the backbone. And that is that. All right, let me see. I need to put area 0. All right, so there's the first one. All right, and then again, the other network is going to go to area 1, and it's going to have a different wildcard and subnet, obviously. So that's going to be 172.20.1.0, and that's going to be 0.0.0.255, area 1. All right. And I think that might be it for router A. Now just going back through and looking at how they do this, 172.20.1.0, 255, yeah, that looks correct. For area 1, yes. All right, so that looks good. And now if we exit out of this, we can do show IP protocols. Let me see, Control A, do Control E, do show IP protocols. All right, sweet. So this gives us a little rundown on what dynamic routing protocol is running on this router. It's OSPF process 1, outgoing, incoming, router ID 172. Now the router ID, I've learned a bit about this. So this is based on the highest IP address on the loopback interface, which is what ours is here. If there are no loopback interfaces, or it could be manually configured, by the way. So if it was manually configured, that would take precedence over everything. The highest configured IP address on a loopback interface is the next up. And then if that doesn't exist, no loopbacks that are configured with IP addresses, the highest normal external interface IP address becomes the router ID from the perspective of OSPF. Routing for networks, 0 and 1, good. Routing information, a distance, etc. So this is kind of cool to see. Routing protocol, blah, blah. All right, we're going to do the same thing. Add OSPF on router B. All right, so let's go here. Exit out of this. We got to get into router configuration mode. So remember router, our type of routing protocol. And then the process ID is 1, and that's that. And now for this one, we need to put the loopback put the loopback network into OSPF area 40. All right, so first things first, we'll do the network 10.0.0.0, 0.0.0.3 area. And now what was the 10.0 network? That was area 0, so that's the backbone area. So that is done. And now we take the other one. Okay, so we see that a neighbor relationship was formed, which is good. So that's good to see. So now for the other one, we need to do network. Now its other IP address is this .192. So let's see. 192.168.1.0, I want to say. And what is 255 minus 192? 63? And I'm trying to figure out the difference between 255 and this so I can know the wild card, which is like the inverse. So first of all, it's going to be 0.0.0. Let's see. 255 minus, I should be able to do this in my head. 255 minus 192, is it 63? Yes. All right, I would have gotten that. All right, so 63. So this is the wild card of this subnet mask. So it's like the opposite. And now this needs an area. And for that, we wanted to put the loopback interface, which is what we have configured up here, into area 40. Okay. And now we can do exit, do show IP protocols to see what its little rundown on this router looks like. Router is 192. So again, the highest configured address on a loopback interface becomes the router ID, area 0, area 40, and that looks correct. All right, so moving on. Area 0, area 40. All right, so check the routing table on your routers. Look for the OSPF advertised network. You will see an IA, which means IA OSPF inter area. You will also see the AD for OSPF, which is 110. Okay, let me see. Do show IP route. All right, and as expected, we see a route learned via OSPF, IA meaning inter area. What did it say? Inter or intra? Inter. So multi-area. Intra is being internal. IA, IS inter area. Okay. Actually, there's a difference between capital and non-capital? I can't remember. I don't think so. All right, so that's fine. Okay, you will also see the AD, the administrative distance, which is 110. Okay, yes, I see that. And that's it for this part of the lab. It says issue some of the available OSPF commands on either router. All right, well, let's just check the other router. What am I doing? On this first router, do show IP route. And it also has a route to the other router. Same thing, 192.168, blah, blah, blah. All right, and that's learned via OSPF. So that is good. Let's try do show IP OSPF neighbors. Neighbor. All right, so we've got one neighbor and it's in a full state. All right, so that's expected. Clearly, this one wouldn't have learned IP OS of a route if it didn't have a neighbor. Do show IP neighbor, and it's got the other router's serial interface as its neighbor. No, it's loopback interface as its neighbor. All right, so the two routers, no, the two interfaces that were in the same area, area 0, were the ones that became the neighbors. And that's, I think, pretty straightforward. And if they're not in the same areas, they aren't going to become neighbors. Okay, moving on. Let's do this next part. So this says basic OSPF, okay. Repeat the previous lab again, but use different IP addressing. Use OSPF area 0 again. Assign IP4 address to the directly connected interfaces, okay. Test direct connectivity using ping, okay. Configure a loopback interface on each. Configure standard OSPF. Ping R2 to R1. Show IP route, all right. All right, I think this is worth going through again. So let's get rid of this. I'll just delete these. And we can just do it real fast again, which is kind of nice when you were working with something like Packet Tracer. You just start over. All right, so we're going to have two directly connected interfaces. I'll use serial link again. Oh, shoot, actually, you know what? I'm not going to use a serial link because I don't want to have to do that configuration. So I think we would just want to use a straight crossover. And we can use gigabit 00 to gigabit 00. Okay, so now they need IP addresses. So the first one directly connected, 10.10.10.1 and 10.10.10.2. All right, so we're going to just go to the CLI. So notice when you don't use a serial link, Ethernet is built in. You just plug it in and you don't have to add that module, that step. All right, so enconft interface gigabit 00. What am I saying? Oh yeah, 0/0. All right, then we need to do IP address. And what's the IP? 10.10.10.1, 255.255.255.0. That's a /24. No shut. All right, good. And 10. No en conft interface gigabit 00. IP address 10.0.0.2, and that's also a /24. And no shut, so these should come up, and they are up now. Can router 2 ping. So let's see, exit do ping 10.0.0.2. Let's see. I don't know why. Test direct connectivity 10.0.1, 10.0.0.2. Oh wait. Oh shoot. Was it 10.10? What is this IP address? Do show IP interface brief. So 10.10.10.1. What is this one? Do show IP. I gave it the wrong address. 10.10.10.2. Okay, so let's see. No, if I'm on this interface, so no IP address 10.0.0.2, 255.255.255.0. All right, and now if I do show IP interface, I should have nothing, right? Brief IEF. Oh, come on. Oh, man. IP See, there's no tab complete when you're using the do command, which is why I hate it. It's annoying. All right, so now the gigabit has no address. So we will, sorry, something is buzzing. Let me just turn that off. Do show IP interface brief. All right, this is annoying. do show IP interface brief. I don't need that. Now I need to redo this. So IP address so that it's on the same subnet. IP address 1010, 10.2, 255, 255.255.0. All right, so now that is no shut. So it should be up again. So can you now ping 10.10.2? Yes, okay. So we have connectivity. Can you ping 10.10.10.1? Do ping 10.10. All right, so when they're directly connected, they need to be on the same subnet. So by putting them on different subnets, they were unable to ping originally. So test direct connectivity using ping, which we just did. Configure a loopback interface on each router and assign addresses from 2 different ranges. Okay, so for the first one, we got 11.11.11.1/32 and 12.12.12.2. All right, so let's see, interface, loopback 0, IP address 11.11.11.1. And that's going to be 255.255.255.255. Now, just to confirm, subnet mask for /32, is it going to be 255? Yes, it is. All right, so just a single IP address, and no shut. All right, and now for this other one, we're going to do loopback 0. So exit interface loopback 0. I can just do it shorthand like that. And that's going to be IP address 12.12.12.2. And that's 255.255.255.255. Then I'll exit out of that. Okay, so configure standard OSPF process 1 and advertise all the local networks in area 0. Also configure a router ID for each device. So everything is going to be in area 0. So you need to go to router configuration mode again, OSPF, process ID 1, and that's that. All right, and we're going to say network. All right, so we had 2 networks. So what do we have? On device 2, we have the 10.10.10.1 and the 11.11.11.1. All right, so let's work on that. Actually, I'm doing router 2 first. Router, OSPF, process 1, network, 10.10. Sorry, 10.10.10.0. And what does it need? It's a /24. So the wildcard is going to be the opposite of the subnet mask. And that needs an area of, it said 0 to use. Okay, good. Now again, the other one is the local or the loopback. So network, the loopback address. Now in order to see this more, can I just say do show IP interface brief from here? Yes, sweet. All right, and now we need to do the /32 loopback address. So network 11.11.11.1, I want to say is the way to configure that. No, it's not. All right, so 11.0, and the wildcard is the opposite of a /32, which is all zeros, and that's area 0. Okay, that's router 1. And it also says to configure a router ID. So we're in, can I say, oh, there we go. Okay. Router ID, OSPF router ID and IP address format. Does it matter? Let me look at the example they do. They use 1.1. Okay. 1.1.1.1. Router reload or use clear IP OSPF process command for this to take effect. Okay. Clear IP OSPF process. Do clear. Reset OSPF process. Yes. All right, sweet. That's done. Router 3, same thing. We are in OSPF configuration mode, so we need to add the networks. And again, let me just pull up the can I do this shorthand? IP interface brief. Does that work? Oh, sweet. That does work. Well, at least I know that I can use the shorthand instead of having to do tab complete. All right, so we're still in router configuration mode. And so we need to advertise these networks. 10.10.10.0, and that was a /24 0.0.0.255 area, and it says to use area 0 still. And then network 12.12.12.0, and that was a /32 area 0. I bet this doesn't work because oh, it did. Okay. All right, so now do show IP protocols, and it has the advertised networks. That's good. Oh, and now I need to do router ID 2.2.2.2. All right, and now we'll do clear IP OSPF process. Yes. All right, so then neighbors went down because we reset the process, but do show IP protocols, and the new router ID is 2222, so that's kind of cool. And I'd like to see that here as well. All right, do show, what am I doing? Do show IP protocols, and its router ID is 1111. All right, that's great. Do show IP OSPF neighbor. So it does have a neighbor again. That's good. All right, so ping R2 loopback from R1 to test connectivity. So R2's loopback address is 12.12.12.2. So our routers are named a little bit differently, but anyway. Do ping 12.12.12.2. All right, so that is not working. What is ping R2's loopback from R1? So R2's loopback address, we configured 12.12.12.2 on, in our case, R3. Let me just confirm that. Let's see. Now, it's possible that they weren't neighbors yet and they hadn't been loading. We're gonna double check. So do show IP interface brief. So it is up and up. The loopback 0 is. And let's try it again. All right, that's not working. So let me get out of this. Do show IP interface brief. Okay, those are both up. Do show IP route. So no routes have been learned via OSPF. And I wonder if that has to do with me clearing OSPF. And I wonder if do show IP so I have routing for the networks turned on. I wonder though if because I changed the router ID and reset that it lost that. Let me ask. So how to bring back OSPF after clear process, Cisco. To restart OSPF after clearing the OSPF process in a Cisco environment, you can use the restart OSPF process command or the no shutdown command on OSPF enabled. The reset OSPF command restarts the OSPF process while no shutdown. All right, so reset OSPF process 1. Reset OSPF process. This doesn't look like it's working. Do reset. Yeah, I don't think that's going to work. So reactivate. If you had previously shut down OSPF enabled interfaces, you can reactivate them using no shut. Okay. You can also reconfigure OSPF by removing and re-adding the router OSPF related commands. Man, okay. So let's see. Interface loopback 0. No shut. Okay, I'll try that. And then interface gigabit 00. No shut. Well, let's try the same here. It looks like they have connectivity. Exit. All right. Interface gigabit 00. No shut. And then exit and interface loopback 0. No shut. Exit. Okay, still no routes learned via OSPF. Which means I doubt we're going to be able to ping. All right, so then we need to figure out how to restart. Do show IP OSPF interface. So it has an adjacency. Designated router 10.10.10.2, 10.10.10.1. Process ID, router ID 111 cost. Internet address is 10.10.10.1/24. And do show IP OSPF interface 10.10.10.2. Well, why ping R2 from R1? Let's just try to ping the normal interfaces. So what is this? Let's try to ping the gigabit. 10.10.10.2. Ping So that works. And then that means, so, okay, what is then this? 12.12.12.2. Do ping. So I don't understand why. Can't ping loopback interface. I really need OSPF, I think, to be able to do that. So I think now that we've got the router IDs reconfigured, maybe I'll just like do it again. So let's try it. So router. So what am I on? Router 2. Okay, router. OSPF 1. Network 10.10.10.0 0.0.0.255, right? And that's area 0. Network 11.11.11.0, and that's 0.0.0.0, and that's area 0. Okay. And now this one, that's router OSPF process ID 1, network 10.10.10.0, and that's 0.0.0.255. Incomplete command, area 0. And then network 12.12.12.0, and that's 0.0.0.0, area 0. All right, now ping R2 loopback from R1 to test connectivity. So again, R2's loopback is 12.12.12.2. Let me do exit do show IP route. Still no routes learned via OSPF, and I feel like there should be. Do ping 12.12.12.2. Maybe I need to create a route. Can I ping the other way? What is this one called? 11.11.11.1. Do ping 11.11.11.1. Okay, so the loopback interfaces cannot ping one another, but the external interfaces can. Let's see. External interfaces can ping, but loopback cannot. OSPF configuration. If external interfaces can ping each other, but the loopback interface is inaccessible despite OSPF being configured, it usually indicates a misconfiguration with the OSPF router ID or a problem with how the loopback interface is being advertised. OSPF uses the router ID to uniquely identify routers in the domain, and if it's incorrectly configured, it can prevent loopback addresses from being learned. Interesting. Yeah, show IP route. Yeah, okay. Reevaluate. If you're using a loopback interfaces for the router ID, make sure it's properly configured with an IP address in up state. If not, okay. Clear the OSPF process to reestablish its configuration and recalculate routes. You might also need to reload the device for that changes to effect. Let's try that. How do I reload this? Should I power it off and turn it back on? I'm just curious. Physical, just turn it off. See how that works. All right, it's off. Back on. And again, physical, off, and back on. So wait for these to come back up, and curious if those OSPF routes get advertised. No. conf t do show IP route. There are no routes at all. No conf t do show IP route. No routes. Now I wonder if do show IP protocols. There's no IP protocol running on this now. So turning it off and turning it back on cleared everything. All right, well, that is a fun lesson to learn. So I think I'll stop this video here, and I'll come back later and follow up with a part 2, but lesson learned, I don't know if that's I think you probably have to write the running config to the startup config so that all of that configuration is saved. Otherwise, when you turn off the router, it just all gets blown away because it's staying in memory. So probably should have thought about that before just like clicking the off button, which is exciting. But anyway, we'll come back to this. I need to research a bit why it could potentially be a thing specific to Packet Tracer. I know there's some odd behavior with Packet Tracer that it may not always match real life, but basically the only weird thing about this little lesson that we were doing was that we manually changed the router IDs for each router for the perspective of OSPF, and after that OSPF routes weren't getting advertised, so need to understand like how to get around that. All right, so that's it for the day. I'll be back soon with a follow-up and maybe some more insight. All right, have a good day. Thanks, everyone.